with me, Lucy Parsons. Welcome to today's show where we're talking about all about how to succeed in A-level physics. So I've got an interview for you today with Simon Petz, who is a teacher with 30 years experience of teaching physics. He used to be head of department, and he also has huge amounts of experience working with all the different exam boards. So he's an author of A-level material for the OCR and Pearson exam boards, a question writer for Cambridge assessments, and an A-level examiner for AQA. So he's fully versed in how exam questions work and how to give the best possible answers. And he's the guest today on today's show, but he is also going to be teaching the How to Revise A-level Physics Masterclass for members of the Extraordinaries Club. And this masterclass is happening live on the 12th of June, which is a Saturday at 10 a.m. So do listen to the podcast. Well, you are already, that's what you're doing right now. But you'll get some really useful tips from listening to today's show. But if you feel like you would like some more detail and the opportunity to ask Simon some questions, then please consider signing up for the masterclass itself. So the things he's going to cover in the masterclass include what successful A-level physics students do right, the best ways to revise A-level physics so that you get the best marks possible, common mistakes when learning A-level physics and how to avoid them, and how to improve your exam technique to get better grades. So, and there'll be lots more as well in that. So if you'd like to find out more about that, you'll find the link for the masterclass in today's show notes, which you'll find at lifemoreextraordinary.com/A-level physics, and A-levels of physics, all one word, no hyphens or spaces. So today's show notes are at lifemoreextraordinary.com/A-level physics. So I hope you enjoyed today's episode, and we'd love to see you at the masterclass, and if you've got any questions about that, please do let us know. Right, let's go over to the interview with Simon. Welcome to the School Success Formula, Simon Petz.
Hello, thank you for inviting me. Slow down.
It's great to have you here. So, Simon, before we dive into the juicy details about A-level physics, can you tell us a little bit about yourself first?
Yes, certainly. I have been a physics teacher all my life, about 30 years now. I have to let you know a secret. I didn't study A-level. I didn't study physics as a degree. I studied metallurgy and material science, but that had an awful lot of physics in, and the natural thing to go on and teach is physics if you want to. And I very much enjoyed it, teaching people and communicating the beauty and wonder of physics, as well as helping them get the best exam results they can. So, but I've taught around the UK, mainly independent schools, and still going, still enjoying it.
Still loving physics.
Correct. I don't think it's something you grow out of, actually. I think once you're hooked in, it's hard to grow out of it. I've never become bored of it or communicating it.
No, I'm probably the same about geography as well. I think when you've been taught to think in that discipline, it's kind of ingrained, isn't it, in your... Yeah. Okay, so first question, what is a good attitude to A-level physics?
I think ultimately you need to be a questioning person. You need to like asking questions, and you need to be strict with your own thinking as well as your own study habits. But in terms of your attitude, you need to like getting things right, but you also need to be comfortable getting things wrong, because getting things wrong can act as a stimulus to you getting them right in the future. And that's what really you need to do. You need to think, well, why don't I understand this? I'm going to dig deep. I'm really just going to read and try and question until I start getting this straight in my head. if you're someone who's happy with a bit of a superficial understanding and thinks, yeah, I sort of get that. Any questions? No, I'm kind of happy with that. You need to ask yourself and your teachers difficult questions, because they lead to better understanding and deeper understanding, as well as a certain sort of disciplined attitude to study, and I think a quite tenacious attitude to study. You're going to get things wrong. You're going to get stuck on things, perhaps more than you were ever used to at GCSE. But you've got to be someone who is comfortable with that, almost enjoys it, and enjoys the challenge of difficult things. I think that's what I see in successful physicists who really achieve the best they can.
That's fascinating. So having a real growth mindset that, you learn from getting things wrong, you want to learn more, being very, curious, but also very determined to get to that complete understanding.
Precisely. I'm teaching someone at the moment, and her attitude is very, when I teach her, I almost do less talking, because she's constantly questioning, saying, well, why is that? Or why is that? Stop there. Tell me why that's that. Which I understand, often in a classroom situation, you can't be constantly doing that. But it's questioning everything, watching, thinking, well, why is that happening? Why are we doing that? Why does that make sense? Why is he saying that? That doesn't agree with what he said 2 minutes ago. And picking up on that, you almost a sort of a lawyer's eye for detail, I would say, is a very useful thing, and plenty of physicists do go on to become lawyers.
And very active engagement of the mind with what is going on. It's not just following a process, but it's questioning every stage of that process to...
Yes, I mean, I guess following is the first step, but also questioning as you go along, and then sort of reviewing and think, okay, well, where have we come? Where are we going? Where's this going next? So the best students, not necessarily the ones that get the highest grades, have an attitude of, well, where's this leading? Okay, does that mean that? And they're already a step ahead. Do you know what I mean? And they're often the successful ones.
Fantastic. It's a great mindset to have as well for life, isn't it? And employment and all that kind of thing. Having that very questioning, problem solving, kind of logical kind of mind.
Absolutely. Yes, absolutely.
Okay, so once you've got that great attitude, how do you go about studying A-level physics, like right from the beginning?
I think you're going to have to recognise that it's a progression. It's a progression, and most people will say that even the ones who ultimately do very well found it the step up from GCSE. But you are on a progression. You're on a journey, and you've got to be aware of your own progress. You've got to be self-critical and think, how far am I to being as good as I can with this particular topic, and that. The journey starts with perhaps the lesson when you're first introduced to something, the teacher introduced something, and you get your head around the basics. You get a general gist, perhaps, of what this is all about. But then, with the consolidation and the notes you make and the practice you do, as well as the homework, you get better at it. All right, it's got to be
practice, isn't it? A bit like music practice, that where you're.
Yes, it's practice. I can give anyone a series of instructions of how to build a table, but unless you actually build some tables, you're not going to be able to do it. Or the older is riding a bike. You're not going to learn to ride a bike without riding a bike. I can tell you very detailedly how to ride a bike, but you've got to do it, and that starts almost after the lesson. The lesson is introduced. Maybe the teacher's given you some questions to do or something, but there needs to be more than that, and there needs to be you writing consolidation notes perhaps as you go along. I think that is quite important, even if you're not told to. Those notes where you just try and summarize something or pick out the main points. It is a difficult skill, actually, when you're first learning the subject, to know what's important, what's not, in your own notes. But I think that will come with practice. But and then don't dive in with difficult stuff. You almost need to be aware and talk to your teacher about, what's difficult, what's easy. Can I do those worked examples in the book first? Okay, read them through, think, do I get it? Hopefully, a couple of readings, you will. Then cover them up. Can I do it now? Okay, can I reproduce exactly the same thing? And that, in a way, that's a bit boring, but it's surprisingly useful and surprisingly necessary to do some of the routine stuff before you sort of try to climb Mount Everest with, past questions. And I think just recognizing, okay, we're going to do some worked example. Often the books will have simple examples there for you to try, just to get the basic wheels turning. And then, maybe after a week or two of immersion in this topic in at home and in the school, then you can try some exam questions. The other useful thing is actually AS is sort of on the way out now, but some of the old AS questions, if you can get them, were set at a slightly easier standard. Sometimes it's worth trying those before you dive in with some of the A-level problems.
Yes.
It can be a bit disheartening, actually, if you try some A-level problems and they're too hard for you straight away. And you have to recognize that you just got to treat it as a progression and small steps, small baby steps, little bit at a time, and you will get better. And once you start to see that you can do stuff, that will motivate you to do even better. And you'll think, right, I get this. I can actually do this. And you'll look to the next stage. Okay, let's try a harder problem now. And, you'll get into those good habits of thought and habits of action for the next topic.
Yeah, so kind of as each topic unfolds, you kind of start with the basics and the easy stuff, and you consolidate that and consolidate it.
Yep.
And as you consolidate, you can expand the difficulty of what you're able to approach.
Exactly. And the other thing I would say is don't try and take on too much at a time. Don't say, you'll progress through the topic at a certain rate determined by your teacher and so on, but don't just get a little bit done well, understood well, before you look more broadly. I had to teach myself some GCSE maths that I had no idea about, had never studied it. And so I started, reading the book and having a go at some stuff. And I realized that I wasn't really getting it. And I wasn't getting it because I was trying to go too fast on my own. And I was trying to take on, 8 different pages of the book at once. And each one I could sort of get. But, the day later I forgot about it. So I said, okay, I'll just take it in smaller chunks, really get this bit, do all the problems. Right, that's okay. And then do that bit. All right. I think sometimes people fall down. It can all seem a bit overwhelming if you try and do too much, and then people get disheartened and they think, oh, this is crazily difficult. That's another thing I would suggest.
That's really good advice. So it's basically learning to walk before you run, isn't it?
Yeah.
Before you run. With the other science A-levels, where I've talked to experts on those, biology and chemistry, they've talked about the importance of reading around the subject. Is that something that you advise for physics?
To an extent, if you're curious, that's good, especially if you might want to go on to study anything physics related beyond A-level. Yes, reading the textbook is certainly quite important. They are written in a certain style. I think find one you like, find one that works for you. Reading around subject is important. Feed your curiosity about it, but ultimately accept that won't be on the exam. What's on the exam is on the syllabus. So I wouldn't go too far unless you have aspirations for, competitive universities, or you want to take physics forward maybe to engineering. I would say more important, because you only have a finite amount of time, and you want to use that time most efficiently to help you. I mean, it can be a good motivator for you. If you're motivated in a subject, if you find it fascinating, great. That's going to motivate you. You're going to think, I really want to do well at this because I quite like it. But I would say reading the textbook is quite important, because that will give a good model for how you should be writing about physics
Yeah.
in your exam. And seeing how it's modeled in a textbook, you'll just pick up those words and phrases and ways of saying things by osmosis. You won't necessarily realize it, but you'll just get a better you'll become a better physics writer, I think.
Okay, that's really interesting, because most A levels, like, people say you've got to read around the subject, you've got to go broader, and it's really interesting what you're saying, and I can completely understand why you're saying it. And I figure that somebody would say the same about maths as well, is that there's not much point in going too broad and wide. You just master the thing in front of you.
Yes. But, I'm absolutely for people feeding their curiosity. But ultimately, if it's good physics writing, it will help you write. And, depending on the level of the maths, it may help you with your maths. But don't treat that as a substitute for knuckling down and powering through a chapter or two of the textbook and trying some worked examples and so on. I think that's much more valuable in terms of ultimate achievement.
Brilliant. Okay, well, thank you. That's really clear on that. So once you've been through your 2 years and you've studied it diligently, how do you actually revise for your A-level physics exams?
I think, first of all, recognise that if you've been studying hard all the way, consolidating, you've worked for topic tests, you've worked for end of year exams, you will have perhaps more latent knowledge and understanding than you think. Okay, you will have a good base level, and you should expect, when you revise, for things to click into place a bit more. By that time, you should have sort of consolidation revision notes that contain the basic factual stuff already in a folder that you've made as you go along. So at that point, it should be, we're talking, prepping for, your final exam. It should be reminding yourself of that, breaking off a small chunk and immersing yourself in it thoroughly, not trying to do too broad brush. I would just go deep rather than wide, probably. Reading through your own notes, maybe reading the textbook again, but more things will click into place. And then it's a question of building your confidence on problem solving as well. And you should be then making a quicker journey towards full-on exam questions. By that time, you've studied it once. It might be worth a few warm-up questions, some worked examples from the book. You could maybe not even show the answer, because the worked examples in the book are generally fairly routine. They generally don't set anything too, out of left field, too challenging on that. Just see if you can do some without going for seeing the answer. All right. And then you can move on to practice. And practice should be a good chunk of your ultimate preparation.
Yes, definitely.
There's, it's probably 20/80, something like that, in terms of knowledge versus skills in applying. And you will find that the more questions you tackle, things do come up again. And you'll think, oh, there was a question like that I tried a couple of months ago. I can't remember the details, but it'll just, little bits of it will still be there. And you'll think, okay, I did that. I've done that. And it's getting the fluency. What you're aiming to be in is in peak fluency at solving physics problems on the day of your exam, ultimately. And you need to sort of time your prep with all the other, demands on your time at the have in the exam season, but treat it as a sort of 2-year process. And the whole of these 2 years is laying the foundation for your final blitz towards the exam season. And if you've done your work in the 2 years, the final blitz things will click into place because you've laid the groundwork. And it might feel that, 2 year and a half ago, you weren't making much progress. But actually, when you come back to it, your brain has matured. You'll be able to make connections. And you'll be able to do things that you never thought you could do. You've got to recognize it. You will get a lot better. Yes. At that age, your brain is very plastic and it absorbs incredible amounts and can do incredible things. And over those 2 years, it's developing incredibly. But you need to get the start from September in year 12.
Yes.
But yes, question practice, blitzing, because, the more fluent you are ultimately in an exam, the faster you can work. And although time is fair, that you need to have to not think about the easy stuff ultimately in the exam, so that you can devote your brain energy and time to the difficult bits which will come up. So yes, so a mixture of things, I suppose, but ultimately it's practice.
Yeah. So but with revision though, it's like consolidate your notes as you go along.
Yep.
Like get comfortable with the basic building blocks of physics.
Yeah.
And by the time you get to the end, you will see how all that fits together to make something complete, really.
Yes, things will click into place. The other thing I would say that sometimes people do ignore is definitions of important quantities. Learn them like lines from a play. Don't try and improvise on the day. You just learn them, okay, word for word, even if at first they don't always seem to make sense. They will do when you've done enough physics and you've worked hard enough for 2 years.
Mm-hmm.
But the definitions are the easy marks. Just make yourself a glossary,
Yes.
ideally, or something like that. Glossary of keywords, or ask your teacher for some guidance on what words should I include, or things like that. The textbooks are quite good, but ultimately, if you're reading a textbook, it is a bit passive. I think you just need to learn them,
Mm-hmm.
and then they are the springboard for actually solving problems.
Yeah.
Because if you get a problem, that says, measure what is the acceleration of something? If you don't know what acceleration is and how it's defined, or you're having to think, what is acceleration again? You're going to be struggling. You're going to be slower. But if it's just got to be at that fingertip, like building a table. If you can't use the file and the saw properly, you're going to be slow at building a table, and you're going to struggle.
Yes. Yeah. So it's that word fluency again, isn't it?
Yep.
So I was going to ask you about exam technique, but have you kind of talked about that already?
There's a few other things I could say about exam technique.
Mm-hmm.
It is important. It's easier, sometimes easier said than done, because I recognise if I took a physics exam, I would actually be quite nervous, and I would feel the pressure. And it is that time, and that I think sometimes you just have to recognise the time pressure. For some people, it's a motivator, and they perform best. For other people, then you have to accept you're not necessarily going to be 10% under par. Yeah. But if you're already 10% over par, by the time you go in, so it can be exam pressure of having to do it under time, I think can be tricky. And accept with yourself, you might make some silly mistakes and things like that. You might do some silly things which you look back and think, well, why do that? But don't beat yourself up about it. Just accept that that's going to happen. But I suppose it's two broad areas. One is the numerical questions,
mm-hmm.
and one is the descriptive stroke explanatory stuff.
Mm-hmm.
And I think with the numerical stuff, practice lots of algebra. If you can, practice those efficient techniques about things like ratios and that type of thing. Get really fluent at your algebra, which will happen anyway if you're doing A-level physics, especially if you're doing maths as well. Small things like checking the units on graphs, checking the units of your answer. Does it look realistic? That type of thing. And also accept that you won't see through to the answer necessarily. It might be something you can do, even if it's a 4-mark question. Think, I'm not quite sure. What am I meant to do here? Just look at the numbers, highlight the numbers. Perhaps some people do that just so they don't have to keep sort of going back thinking, what was V again? Mm-hmm. So just help yourself visually, perhaps. And if it's not happening, just move on to the next one. In terms of descriptions and explanations, I think that is quite an important one. I think learning, in a way, they're testing, can you use the language of physics?
Yeah.
And if you've read the book, and you will be good. You will be good at that, but just try and use those keywords.
Yeah.
And keep your sentences short, I would say. Don't tie yourself in knots with commas. Just keep it direct. Keep it as simple as you can. Use those connecting words like therefore, because, as a result, if you're trying to explain, say, why things happen. Don't use the word it. Refer to the noun specifically. It's about, really, physics is about, it's a very hard skill, actually, communicating clearly some tricky concepts. Even in simple, you can ask a simple question, and actually there's a million different ways of expressing something. Yes, so the fine thing is it's essentially about communication exam technique, and that means taking time, just a bit of time and care to communicate clearly, like graphs. Have you included a scale? Is the line clear? Always bear in mind, someone else is going to be reading your answer. It's not whether you understand it, it's whether you can convey that to the other person. So you almost need to have a little mental picture of someone reading your answer as you write it. Keep the other person in mind. You're not writing it for yourself. Yeah. Sometimes when I'm marking, I think I see some answers and I can sort of see what the person's doing, but they're not really convinced me.
Yes.
A phrase that markers, examiners sometimes use is, don't make the examiner do the work.
Yes.
To read between your lines, you show them. This is your chance to show how good you are at physics. You are on stage, all right? And you will be very good at physics. Just show the person.
Yeah. I always say, learn to think like an examiner.
Yep.
So you get into their head and you understand how they're looking at your work, how they're reading your work, and how they're comparing it to the mark scheme and all that kind of thing.
Yes, they're not looking for faults, I would say, but they will be aware of that. They'll be aware of slight ambiguities in what you're reading, what you're writing, or the way you say things. Or have on a show that question. So questions to show that this formula applies or whatever. Have you convinced them? Have you really shown them? You almost need to make your answers legally watertight.
Yes.
Which is a strange thing, but again, you don't always have time. You're thinking on your feet. You've got to get on to the next question. It's hard to do, but you've just got to think, have I covered all the bases here? And sometimes I see answers which people have gone back to and they've cut something out and put a star in. And although it's a bit messy, that they've self-corrected.
Yes.
And they've thought, oh, hold on, that doesn't make sense. Let's change that phrase. Or they've added another one or something. But it's just being unambiguous and completely watertight in what you're saying.
Yeah, definitely. That's good advice for any exam, really, isn't it? Not just physics. Okay, so lots of people perceive A-level physics as being really, really hard. Why is that?
Because it's a hard subject.
Okay, fair enough.
It is hard. Just take a step back and think what you're trying to do with A-level physics. A lot of the very, very cleverest people that have ever lived took 300 years to solve a lot of physics problems, and you're being asked to do it and assimilate it and learn it in, or maybe not 2 years because you've done some before, but very quickly you're being asked to appreciate and learn something that took a long, long time to work out. And that is hard. A lot of the concepts are very abstract and very mathematical. So you're combining a lot of different skill areas, such as numeracy, data processing, rigorous thought about abstract concepts, three-dimensional visualization, which is, well, if that moves this way and that moves that way, where are they going to collide, or something like that. And very high demands on your use of language as well to express precisely some quite complex things. It is great training if you have to write, actually, in certain fields, perhaps not poetry and novels, but in certain professions, physics is a fantastic training in how to write accurately. And you've got the theoretical aspect, but you've got also the practical aspect. You've got to have some appreciation of practical physics and how things fit together and those sort of mechanical things, as well as just the purely theoretical. So it draws on an immense amount of skills. And I think that's partly what makes it hard.
Yeah, I love the way you explained, it took 300 years for lots of very, very clever people to discover this stuff, and you're trying to learn it in 2 years.
Yeah.
That kind of boils it down.
Yes, just be that's it's understandable. It is difficult.
Yeah. And lastly, Simon, what does it take for somebody to reach their potential in physics?
It takes a determined attitude, hard work, and motivation, a lot of motivation, and you will reach your potential, because ultimately that's what the exam side is designed to do. But you've got to do the groundwork. I think you've got to, while using your teacher and working with your you've got to learn to fly a bit more on your own, certainly at A-level. That's a general, perhaps, quality of an A-level student, perhaps. But a questioning attitude, hard work, and then you will achieve what you can, because in a way that's what the exams are designed to do. They're designed to separate out the very best from the weaker physicist on this spectrum of grades. Just recognizing when you're making progress.
Yeah.
And just taking that in and thinking, okay, that's going to motivate me to do better. Just not get stuck, but don't get completely disillusioned and disheartened.
Yeah, and remember that getting something wrong is an opportunity to learn and get better, rather than an indication that you're never going to get it. Yeah,
absolutely.
Fantastic. Well, that's been really, really helpful, and I'm sure the people listening will have got a much better insight into what it takes to succeed in A-level physics from listening. But it would be amazing if people can join us for the How to Revise A-level Physics Masterclass on the 12th of June. If people are interested in that, you'll find a link to sign up for it in the show notes, and that you'll find the show notes for today at lifemoreextraordinary.com/A-level physics. So thank you so much, Simon, for sharing your experience and your knowledge with us all today. We really appreciate it.
Yeah, it's been fun. I'm looking forward to the masterclass, and thank you for inviting me on. It's been interesting.
Yeah, we are. We'll look forward to it. So thank you so much for listening. Have a wonderful day, and goodbye.
Thank you very much. Goodbye.